All right, welcome back. Today we're going to do a little bit of an investigation on end behavior and talking about end behavior as it pertains to end behavior asymptotes or horizontal asymptotes or these end behavior functions. So let's go. As far as end behavior is concerned, what we've studied so far is our horizontal asymptotes. Okay, and so we've looked at the Bobo, Betsy, and Bo2 cases. So for example, if I have a function, so this will be Bobo, so the bigger on bottom, y equals 0 asymptote. So for example, if I have, I don't know, an x squared plus 5 over x cubed, something like that, my asymptote will be at y equals 0. Well, as my function goes out to infinity, or it goes out to negative infinity, my limit is going to be 0. On this side, my limit is going to be 0 as well. As I go out to the ends, it's 0. So I'm squishing this in because this is review. As far as Betsy is concerned, if we've got bottom equals top, then it's the coefficient, so like a 3x squared plus 1 over x squared minus 3. So our horizontal asymptote would be at 3, so y equals 3. And so our graph would look something like this. I'd have, and then sort of put in my asymptote here, and then as I went out to infinity, my graph would come closer and closer and closer to 3. So my limit would be 3 as x approaches infinity, and my limit as x approaches negative infinity would also be 3. These horizontal asymptotes tell me exactly where my limits are. But with the Bo2 case, our horizontal asymptote is undefined because there is no horizontal asymptote. So in this case, what I'm looking at is I have an end behavior asymptote. And my function looks something like this. It'll be like an f of x over a g of x. Well, my end behavior asymptote looks like this. I divide and I get my quotient plus my remainder. This part here is my end behavior asymptote. Not this. This part, the quotient, what I get before the remainder or what I get without the remainder is the end behavior asymptote. Okay, so that's our new concept. So Bobo, Betsy, and Bo2, old. Limits, approaching horizontal asymptotes, old. End behavior asymptote, dividing and taking just the quotient, not the remainder. That's the new part. Vertical asymptotes are formed by the restrictions in the domain. And my x-intercepts are going to be where f of x is equal to 0, specifically denominator equals 0, as long as it doesn't make the numerator 0 as well, which wouldn't work. And our y-intercept is where we take f of 0. So we plug in 0 and we figure out where our y-intercept is. Okay, that's the basics. What are we doing with this? Well, we're going to take this and we are going to find end behavior asymptotes. Okay, I've given you 3 examples up here. All of this you should be able to do, and then when you get to these end behavior parts, that's going to be the new part. But I want to skip to this example here, finding an end behavior asymptote. They've given us f of x. Now, I'm going to evaluate it for the end behavior asymptotes. So they've kind of given away what we're supposed to do, but I'm going to look at this anyway. I'm going to look at the horizontal asymptotes, and if it's bigger on top, so this is undefined, that's going to tell us, okay, I've got an end behavior asymptote. So end behavior asymptote. So how do we do this? We have to actually divide. So because I have an x minus 1 down here, I can do synthetic division. So I'm going to pick 1 here, and I'm going to put in my coefficients. 1 minus 3, 3, and 1. Bring down the 1, multiply, and add. Multiply, and add. Multiply, and add. So what do I have? Right now I have a function, and I have a remainder. This is my remainder. I'm not concerned about my remainder. I'm concerned about this. This part is, so I started out with a cubed. This is x squared minus 2x plus 1. This, right here, this is my end behavior asymptote. Okay, that's my end behavior asymptote. Let's put it on a graph and see what it looks like. All right, so let's take a look. Here, I graphed my original function, and then I graphed just the quotient, not the remainder. I don't have that extra piece, that extra remainder. And look what happens here. My red is my original function. Well, you're thinking to yourself, they kind of overlap. Like, what's with that? What's going on? Let me zoom out and show you. As I zoom out, you see what happens? Maybe you missed it. Check it out. Look at my functions. My blue function, which is my end behavior asymptote, and my red function, now I've got this extra little piece in here, but I'm not concerned with that piece. I'm looking at as x goes to negative infinity, as x goes to positive infinity, what does it look like? Well, look. They are so close together, they're indistinguishable. So if I would just zoom in on just this part, look at this. See how close they get together as I go up and up and up and up and up? And so my end behavior asymptote tells me as x goes to negative infinity, as x goes to positive infinity, this is what the ends of the graph are going to look like. Okay? All right, I've got one for you to try. Try this one. Find the end behavior asymptote of x squared minus 2x plus 3 over x minus 5. So pause the video here, try it. When you come back, I'll do it with you and for you. All right, we're back. So our function here, we're going to find the end behavior asymptote, obviously bigger on top. So we've got the bow 2 situation. We're just checking to make sure that we actually have one. So when I divide, I'm going to put 5 on the outside, do my synthetic division, 1, negative 2, and 3. Bring down the 1, multiply by 5, add to get 3. 5 times 3 would be 15. So this is 18. This is my remainder. And so this is my end behavior asymptote. And it is, original is x squared, so it is x plus 3. That's my end behavior asymptote. All right, guys, that's the basics of it. Thanks for watching, and we'll see you next time.